One agent, one prompt. What could go wrong? Let's find out. Imagine you give an AI agent one massive request, build a full stack web app with authentication, a dashboard, unit tests, and deploy it. At first, it starts great. It sets up the backend, writes the auth logic. Now everything looks clean. But it starts losing track. It forgets the database schema it wrote earlier. It tries building the front end while thinking about tests. The context window fills up fast, and the agent begins hallucinating. It imports libraries that don't exist, calling functions it made up. The context hits 97% and it crashes. One agent simply cannot hold an entire software project in its head. This is exactly why we need multi-agent systems. If you are learning something new, hit like and subscribe because this gets really good. So what if instead of cramming everything into one agent, we split the work into a team? First, the coder agent fires up. Its only job is to write the login API. It uses fast API, creates the endpoint, generates the JWT token, and it's done. Notice how its context usage is only 18%. Next up, the tester agent gets the code. It doesn't care how the code was written, it just runs the test suite. 2 tests, both pass, and the context usage just 12%. Finally, the DevOps agent takes over. It pushes the container, deploys to Kubernetes, runs the health check, and we're live. Only 9% context used. 3 agents, 3 focused contexts. That's the power of multi-agent systems. But how do these agents actually coordinate? They're not just chatting randomly, they follow a graph. It starts at the start node. The task flows to the coder agent through an edge. The coder wakes up, reads the task, and begins writing code. Once the coder is done, it writes the code into the shared state, like a clipboard every agent can read, and passes it down to the tester. Now here's the clever part. The tester finds a bug as missing input validation. So it updates the state with the error and moves the task back to the coder. This is a conditional edge. The loop continues until the code is clean. Once all tests pass, the state updates to end and the workflow completes. This is how modern frameworks like LangGraph build reliable, self-correcting multi-agent systems. Let's see how easy it is to build this using LangGraph in Python. First, we define our shared state. It's just a Python dictionary that holds the task, the code, and a list of any errors. Next, we define our graph and add our agents as nodes. We have our coder node and our tester node. Now, for the magic, we draw the edges. The coder always passes its output to the tester, but for the tester, we add a conditional edge. If the tester finds bugs, it routes the state back to the coder. If everything passes, it ends the workflow. Finally, we compile the graph and invoke it with our initial task. The agents will loop back and forth automatically, fixing bugs until the code is perfect without you lifting a finger. When should you use which? Let's break it down. Single agents are simple, fast, and cheap. One brain handles everything. They work perfectly for simpler tasks like Q&A, basic code generation, or data summaries. Multi-agent systems shine when tasks get complex. Each agent owns one job, letting you scale to complex workflows like writing, testing, and deploying code without blowing up your context window. However, multi-agent systems are more expensive and slower. Every hop between agents is another API call. Do not over-engineer. The golden rule: start single, scale to multi only when the task gets too complex for one brain to handle. Quick recap. The core problem is context overflow, single agents trying to hold an entire complex software project in one brain and crashing. The solution is breaking that large task into a network of specialized agents. Each agent does one thing well, communicating through shared state. In the next episode, we take everything we built, tools, memory, and multi-agent graphs, and show you how to deploy them to production. If you found this helpful, please hit like and subscribe so you don't miss the next one. See you there.